Welcome to Easy BTech, your guide for BTech and beyond. The today's topic we will discuss regarding the SCR, Silicon Control Rectifier. Okay, students, SCR. SCR is nothing but it is a Silicon Controlled Rectifier. Okay, majorly for low voltage rectification purpose, low voltage rectifier purpose, we use diodes. For high voltage rectification purpose, high voltage rectifier purpose, we use SCRs, silicon control rectifiers. Now what is a rectifier? You know what is a rectifier? which converts which converts bidirectional signal bidirectional signal into a single direction signal. Means in a rectifier which converts an AC to DC, which converts AC to DC, AC to DC. But practically and strictly speaking, which converts AC to pulsating DC, AC to pulsating DC, which converts AC to pulsating DC. Okay, students, now you can see these SCRs. SCR generally constructed from PN materials, which is a thyristor family. Thyristor family. Okay, now you can see okay, it is anode, it is cathode, it is J1, it is J2, it is J3. Okay, J1, J2, J3. It has three junctions. Okay, it has four layers, and three junctions. Four layers and three junction. Like how we will see like a Schottky diode, Shockley diode. Shockley diode. Okay, three junctions, four layers. This is we can represent P1, N1, P2, N2, and across this we will call a one layer. This we will call as a this layer here. This layer called as a gate. This is an SCR construction. SCR. It has anode, cathode, gate terminal. It has four layers. Okay, it has four layers, three junctions, and three terminals. Three terminals. Those are gate, anode, cathode. Layers 4, P1, N1, P2, N2. Junctions 3, J1, J2, J3. Is it clear? Now you can see clearly from the diagram. Uh, Externally we are applying this SCR operations. SCR operations are generally categorized in three parts. In three parts. That is first one is IJ, gate voltage 0. Second one is gate voltage less than 0. Third one is gate voltage greater than 0. In these three cases we can see. Now we will see case 1. When gate voltage is 0, no voltage is applied across the gate terminal. Then IG is 0 and open. IG means gate is open in this case. Now what happens when gate is open? Gate is open. Now you can see now it is P1, N1, P2, N2, J1, J2, J3. Now here not applying any terminal. Now it is anode, it is cathode. Now you can say when a positive voltage is applied here and a negative voltage is applied here positive and here negative voltage is applied, then when externally positive voltage to the gate and negative voltage to the cathode, positive voltage to the not gate, positive voltage to the anode and negative voltage to the cathode, then J1 and J3 junction, this J1 and J3 junctions are forward bias. J1 and J3 are forward bias. Okay, and gate is open, and then gate is open, then P2, that is J2 junction is reverse bias. J2 junction is J1 is in forward bias, J3 is forward bias due to their polarities applied externally to the terminal anode and cathode. J1, J3 forward bias, J2 reverse bias. J2 reverse bias, no current will flow. Suppose if a larger, if external voltage is applied, if external voltage is applied greater, then current flows through the current flows through the transistor. That is, current flows through the SCR. Then it turns on. Then it turns on. Okay, that we will see that from the diagram. You can see here. The current. This side is a voltage. It is a normal PN junction diode. This is avalanche diode or ordinary diode. Basic model. But in this SCR, when Ig 0, now here the characteristics you may see here, forward bias. The current through the diode increases up to this point, VBO, break off point or firing or break off point, break over voltage. Is it clear? It means when SCR is turned on, okay, up to, it means you can see here very clear, no doubt. Say when a voltage is applied across here, J1 is forward bias, J3 is in forward bias, J2 is reverse bias, due to which current flows here. Now when this external voltage is increased, then a huge current will flow, then the SCR will be completely turned on. SCR will be completely turned up to VBO breakover point. The transistor flow, the current flow through the SCR is very small. After when it reaches the breakover point, that is a firing point, or breakover point, the SCR turn on. When this SCR turn on, it starts decreasing the input voltage. And a huge current will flow. This point we will call as a VH holding voltage, and this current we will call as a IH holding current, and this we will call as a IB naught breakover current. Is it clear? It means from this point to this point, this we will call as a negative resistance. Negative resistance characteristics. Negative resistance. Is it clear? It is very clear, ma. When input voltage is applied between anode and cathode, when gate is open, a huge current can flow in the SCR by increasing an external voltage. That is known as a holding voltage. Suppose if you want to make the SCR off, what you have to do? If you want to make the SCR in an off state, then you can decrease the voltage below the holding current. Okay. Here the SCR is on. SCR is on state. Okay. To make SCR is off state, decrease input voltage less than holding VH, then the SCR can be turns into off. Okay, this is about when Ig is 0. Next step. when Ig is when Ig is less than 0, when Ig is less than 0 means a negative, when Ig is less than 0. Now you can see here, this is an SCR, this P1, P1, N1, P2, N2. It is a gate terminal, it is a positive anode and negative cathode. Cathode. It is a gate. Now what second case when Ig is less than 0? When Ig is less than 0. It means what you can see here, when gate voltage is negative. Now what happens you can see here clearly ma. Positive to positive. J1 is in forward bias, J3 also in forward bias. If you give more negative to the P, more negative to the P, what happens? A reverse bias. It means across J2 junction, across J2 junction, it becomes reverse bias, reverse bias. Then it requires more breakover point, breakover voltage. Breakover voltage is increased. Okay, by then after this anode to cathode voltage is increased further, then it starts conducting. Then it starts SCR turns on. SCR turns on when uh, when this exits the breakover point. When it starts firing. When it starts firing after the breakover point, it starts firing. Is it clear? It means as a negative voltage is applied to the gate, breakover point is increased. Breakover point is increased. That is the concept. Okay. Now you can take one. Now this is a breakover point now. This is VB naught. For what? Ig less than 0. Ig less than 0. Is it clear? VBO is increased. VBO is increased. When SCR is turn on by increasing anode to cathode voltage. By increasing anode to cathode voltage, SCR is completely turned on. To make SCR off, to make SCR off, what happens? Decrease holding voltage. Decrease holding voltage. Okay. Next, third point, third case, when gate voltage greater than 0. Gate voltage greater than 0. This condition you can see here clearly. P1, N1, P2, N2. This is gate, anode, cathode. This is J1 junction, J2 junction, J3 junction. Now you can see here clearly as Ig greater than 0 means gate voltage is a positive. When it is a positive, gate voltage is positive. When gate is positive, P2 is positive forward bias. It means now here by applying here positive voltage, here negative voltage, now what happens? J1 is in forward bias, J2 is also forward bias, J3 is also forward bias. Okay, forward bias, forward bias, forward bias. Now SCR completely on state, completely on state. Is it clear? Now what happens? The breakover point will be reduces. The breakover point will be reduces. The breakover point will be reduced. For this is a breakover point. This is VBO. This is for gate voltage 0. This is for gate voltage greater than 0. This is a holding current. To make the SCR of decrease the voltage less than the holding current, holding voltage less than VH, the SCR completely off. Okay. Okay, students. Easy BTech guide for BTech and behind. Thank you.